Okay, in number 6, we have a pattern made from toothpicks, and we're given 3 diagrams. And this right here is one toothpick. Okay, so in A, we need to create a table comparing the diagram number with the number of toothpicks. So when we draw a table, get something like this. Let me make this a little bit longer. Okay, and then we have 3 diagrams, so we need 4 rows. Okay, so here is the diagram number. So diagram number, and here is the number of toothpicks. So number of toothpicks. And we know that there's 3 diagrams, so 1, 2, and 3. And we know for the first one there's 1, 2, 3, 4 toothpicks. In the second one there's 1, 2, 3, 4, 5, 6, 7. And in the third we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So in diagram 3 we have 10 toothpicks. Okay, so that's our chart in A. Now for B, we need to find the first differences to show if this pattern is a linear relation. Okay, so first difference between diagram 1 and 2 is 7 minus 4, which is 3. And then from between diagram 2 and 3, it's 10 minus 7, which is also 3. And clearly these two are the same. So the first differences are the same, which means this is a linear relation. And then in C, we have to write an equation that relates this relation. So diagram 1 with the number of toothpicks. Okay, so let's let, D equal to the diagram number. And then let's let T equal the number of toothpicks. Okay, and we know that for every diagram we move up by 3 toothpicks. So T has to equal 3D. It has to look something like this. And when we plug in D equals 1 for diagram 1, we get T equals 3 toothpicks. But we have 4 here. So how do we make 3 into 4? We add 1. That way this equation works for the first diagram. Now we have to test if this equation works for the second and third as well. Well, when we plug in D equals 2, we get 3 times 2 is 6 plus 1 is 7. 7 toothpicks. So it works for diagram 2. Now what about 3? We plug in 3 and we get 3 times 3 is 9 plus 1 is 10. So 10 toothpicks. So this equation works for all of our diagrams. So therefore D equals 3D plus 1 is our equation. And then finally for D, we have to use this equation to extrapolate to predict the outcome for the 10th step. So when we're at the diagram 10, so when D equals 10. Okay, so T has to equal 3 times 10 plus 1. And what's 3 times 10? That's 30. And then we add 1 to that and we get 31. And what's T? T is the number of toothpicks. So therefore, in diagram 10, there are 31 toothpicks.